Hello, I welcome you all to this another interesting screencast. The problem reads, the man attempts to pull the log at sea by using the three ropes. Determine the direction theta in which he should pull on his rope with a force of 80 pounds so that he exerts a maximum force on the log. What is the force on the log for this case? Also, determine the direction in which he should pull in order to maximize the force in the rope attached to B. What is this maximum force? This problem is coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so we have this man here pulling a log, and one rope is tied to a static point at B. Alright, so first things first, we are going to draw the free body diagram, but before we do so, let's section these cables that have been used to pull this particular log. So once we've done the sectioning like so, then we expect a tension force like so. Like so, another tension force there, like so, another tension force like so. Alright, and then let's assume, let's assume, or let's have our coordinate system as shown. Not assuming, right? We are determining our coordinate system. This is our coordinate system, and this one too, like so. Right, so this is the y, positive y. This is x. Great. So let's draw up other components. So we are going to have a component in this direction from this force. Let's label these forces. This is AD. Okay. This is AD2. This is AB. This is AB2. This is AC. And this is AC2. Alright. So we expect to have a component in this direction, have a component in this direction like so, and then have another one like so. Alright, and then these are from AD. Then we expect to have another component from AC like so, and another one like so. Alright, but we know that this angle here is just going to be equal to 180 minus 150, right? So this is equal to 30 degrees. So this force here becomes equal to AD cos theta, and this is AD sin theta. And this one is AC cos 30. This one is AC sin 30. Right. Of course, our reference is A, which is 0, 0, 0. So let's apply the equations of equilibrium. Summation of forces in the y equal to 0. So we're expecting the x. We have a minus AC cos 30 plus AD. Sorry, let me start with AB. AB and minus AC cos 30 and plus AD cos theta equal to 0. And then see summation of forces in the x. How do I, yes. Okay, and then summation of forces in the y. Summation of forces in the y. We have minus AC sine theta, sine 30 degrees, then plus AD sine theta equal to 0. Okay, right, so we are going to make AB and AC subject to the formula. So if we did so, then we have AC is equal to AD. We know that AD, we've been taught that AD, this is the force that is being applied. AD is equal to 80 pounds, right? So this AD sine theta divided by sine 30, which is just going to be equal to 80 sine theta divided by sine 30, sine 30. Okay, and we can plug in this value and plug this value here. Okay, so once we do so, we're going to have AB equal to 80 cos 30 divided by sine 30 times sine theta minus AD also, that one is 80 cos theta. So we can simplify this later on as AB is just going to be equal to 80 open brackets cos 30 divided by sine 30 sine theta minus cos theta. Okay, alright, so we have these two equations. So we have these equations. So there are a number of ways to solve this particular problem. One of the best ways is, or one of the ways, not the best ways, is every time we see this maximizes, then what we should always think of as one of the alternatives is using derivatives, right? Using derivatives. Okay, so let's take our interval. Let's assume this is our interval. Theta is going to move from 0 to 180. Okay, so let's say our domain for theta is from 0 degrees to 180 degrees. Okay, so let's start with the first one. So we have AC as a function of theta, which is equal to 80 sine theta divided by sine 30. Okay, derivative of that dAc, which is a function of theta with respect to the theta there, this is just going to be equal to 80 cos, let me just put it down here, 80 cos, derivative of sine is cos, positive cos theta, and of course this is a constant down there. Okay, and when we want to find the minimum or the maximum, we equate the derivative equal to 0. So we are looking at the interval theta between 0 and 180. So when is theta cos theta equal to 0? So we know that, so we can solve this. Either you make cos inverse of 0. So you find that theta here is just going to be equal to 90 within this interval, right? Alright, we know cosine is like so, right? Cosine function, right? At 90, this is 90. Okay, this is 180. This is 270. This is 360. So at 90, cos is 0. At 270, it is 0 also, but we are just looking at the interval 0 to 180. So 90 degrees. So we found one value and we want to calculate. We find the value of AC. So what is AC at 90 degrees? AC at 90 degrees, this is 80 at sine 90 divided by sine 30. This gives us sine 90 divided by sine 30 times 80. So this gives us 160 pounds. So therefore theta equal to 90 degrees will give us AC max equal to 160 pounds. Alright, we found one case. We have two cases. Let's find the other one. The other one says, nice to move this. This is the furthest I can go. Right, the other one says we also find the maximum force in AB. So again, we're going to use the derivative. So we'll say AB, which is a function of theta, we found this to be equal to 80. This is 80, open brackets, cos 30 divided by sine 30 times sine theta minus cos theta. So if we are to work out this, so we'll say derivative of AB with respect to the theta is just going to be equal to 80. Okay, then this is just a constant, cos 30 divided by sine 30. Okay, then sine becomes cos theta, then minus, then another minus cos theta becomes minus sine theta. Okay, minus minus. So this therefore becomes a plus. Then this, of course, is equal to 0. All right. So we can factor out the 8 there. So what we just remain with is just cos 30 divided by sine 30 cos theta plus sine theta equal to 0. If we are to write this, okay, divide through both sides by cos theta, then this becomes tan theta is just going to be equal to minus cos 30 divided by sine 30. Therefore, theta is just going to be equal to minus cos theta divided by sine 30. Tan inverse of that is minus 60. But our interval, we said theta is from where? From 0 to 180. So we need to add this. We need to add it to 180 so that we get the interval. So if we were to check here, this minus just says minus. If I was to draw here, minus, this is coordinate system. Minus is just moving clockwise from the horizontal axis. This is what it means, right? This is 60 degrees. But we are not interested in the minus. We're interested in the anti-clockwise. Okay? Anti-clockwise. So we're interested in this. You see this one? Okay? So how do we get this? So we just say 180 minus 60. Alright, is that fine? Should be fine. Great. Therefore, our theta is just going to be equal to 180 degrees minus 60, which is equal to 120 degrees. So theta, let's find what AB is at 120. So AB at 120 degrees is just going to be equal to, let's plug it in, AB at 120 is just going to be equal to, let's plug it in, 120. So we're using this equation here, this equation. Okay, so we have cos 30 divided by sine 30, okay, times sine 120 minus cos 120 times 80. So this gives us a 160. Okay, this gives us a 160. So therefore, at theta equal to 120 degrees, we have AC max, AB max, not AC max. Okay, AB max equal to 120 pounds. Okay, let me just move it a little bit like this. Right, I think we are done. Let's just outline our solution. So we have this value of AC max at theta equal to 90, and we have this maximum value of AB at theta equal to 120. So I hope the video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.